All right, this is a stoichiometry problem. We start with the amount of some reagent, and then we're asked to compare that to the maximum amount of product. Let's consider a map to this problem. We're given a mass of elemental carbon, and in order to relate that to anything else, we have to immediately go to moles. So then we have moles of carbon. That's converted to CO2. We can use a mole-to-mole ratio here, a 1-to-1 mole ratio. And then our CO2 is then converted to our urea product. And then we simply have one more step to get to grams of urea as our product. So each of these individual arrows corresponds to a conversion factor. To go between mass and moles, we'll have to use the atomic weight. Here, we'll go to the mole-to-mole ratio, and also here. Note that you never need to know what the mass of carbon dioxide is. You can just simply use the mole-to-mole ratio to go from carbon to CO2 directly to your product. In the last step, we simply use our formula weight of urea to go from moles to grams. So let's do our calculation. So we start with 1 times 10 to the third kilograms, and that would be equivalent to 1.00 times 10 to the sixth grams. Then we can use 12.01 grams per mole of carbon. Every mole of carbon is going to result in a mole of CO2. And it's also a 1-to-1 ratio between CO2 and urea. Finally, we can multiply by our atomic weight of urea. And we get our final answer. Before we do our calculation, let's check our units. All right, grams cancel, moles carbon, moles CO2, and moles of our product. So we have grams of our product. We look good. So let's do our math. The calculator answer I get is 5.0017 times 10 to the sixth grams. Let's look at sig figs. Okay, in our first number here we have 3 sig figs, 4. This is exact, so it does not impact sig figs. This is also exact. And this number has 4 sig figs. So we're limited to 3 sig figs in our final. We can express our answer in either grams or kilograms. So it's 5.00 times 10 to the sixth grams. Or we can write 5.00 times 10 to the third kilograms.